Well, we'll use 3 examples to introduce how to solve circuits with the 3 elements method. For such a simple circuit, we should find the voltage UC, UR, and current I with 3 elements method easily. The given condition is UC 0 negative is U0. We will list the 3 elements of UC, UR, and I respectively. UC0 plus equals to UC0 minus equals to UC0. In order to get UR plus 0 plus, we need to draw the 0 plus equivalent circuit after switching. You can see UR0 plus equals US minus U0, and I0 plus equals US minus U0 over R. In order to solve steady-state value, we draw the steady-state equivalent circuits. Obviously, the capacitor is open, so the steady-state value of UC equals US. Similarly, the capacitor is open, so the steady-state value of UR equals 0. And the steady-state value of I equals 0. Then we find the time constant. For such a circuit, tau equals RC, RC, and RC. You should remember the expression of any branch variable of first-order circuit is steady-state value plus 0 plus value minus steady-state value multiply e to the power minus t over tau. So UC equals US plus U0 minus US multiply e to the power minus t over RC. UR equals 0 plus US minus U0 multiply e to the power minus t over RC. I equals 0 plus US minus US over R multiply e to the power minus t over RC. In these expressions, t is greater than or equal to 0. You see, this method is very easy and its physical concept is very clear. This circuit is a little more complicated. Before applying 3 elements method, you can see it's not easy to list ODE related to UR. Let's use 3 element method. In order to solve the steady state before switching, we draw 0 minus equivalent circuit. You should notice we only need to solve the capacitor's voltage or the inductor's current in the steady state before switching. In this circuit, UC 0 minus equals 2 volts. In order to solve UR 0 plus, we need to draw 0 plus equivalent circuit in which the topology is changed and the capacitor voltage is substituted with 0 negative value voltage source. This is a resistive circuit. Mark UR. By applying KCL on this node, we find UR over 2 plus UR minus 2 over 1 equals 1. This current flows in this direction. This current flows in this direction, and this current flows in this direction. By solving the equation, we got UR 0 plus equals 2 volts. In order to find the steady-state values after switching, we draw the steady-state equivalent circuit. This is a resistive circuit. 1 ohm connects to 1 ohm in series and connects to 2 ohm in parallel. So 1 ampere is divided into 2 branches. We can easily get the steady-state value of UR due to current division formula. At last, we need to solve the time constant tau. There's only one energy storage element, that is a capacitor, in this circuit, so it's first-order circuit. Tau equals RC, and C equals 4 farads. What's the value of R? Let's review Thevenin theorem. The equivalent resistance seen from the terminals of capacitor to the outside is just R in the time constant. In order to solve tau, we need to draw the Thevenin equivalent circuit seen from the terminal of the capacitor to the outside. All the independent sources take no effect when we solve Thevenin equivalent resistance. This is the Thevenin equivalent circuit. Seen from terminals A and B to the outside, Req equals 1 series to 2 parallels to 1 equals to 3 over 4 ohm. So tau equals 4 multiplied 3 over 4 equals 3 seconds. By taking them together, we know URT equals UR infinite plus UR0 plus minus UR infinite multiply e to the power minus t over tau. By substituting numerical value, we know it equals 1 plus 2 minus 1 multiply e to the power minus t over tau, which equals 1 plus e to the power minus t over 3, in which t is greater than or equal to 0. Thus, we've completed the analysis of these relatively complicated circuits with a simple method. Before the next exercise, let's do a summary. In order to solve the circuit, we draw 4 equivalent circuits, which are zero negative circuit, zero plus circuit, steady-state circuit, and a Thevenin equivalent circuit for solving tau. There are several notes for you. Firstly, all 4 circuits are all resistive circuits. It's effective to use the node voltage method, loop current method, superposition theorem, and Thevenin theorem, and other circuit analysis techniques. Secondly, we focus on any branch variables, 0 plus value after switching, steady-state value, and change speed. There are 3 key elements to find the solution of the circuit. The whole solution is full of bright physical characteristics. This is the most important characteristic of 3 elements method.